Section 8, Solving Radical Equations and Inequalities. This is the last topic of this chapter, so pretty soon we'll be having that test on these sections 6, 7, 8 with the radical equations and functions and stuff like that. And you knew that solving was going to be in here pretty quick, so here it is. Our learning target today for the topic of solving radical equations and inequalities is awe-inspiring. I can solve radical equations and inequalities. Brilliant. And we only have one. I thought about splitting that into two, but not worth it. So let's look at solving radical equations. Now I could explain how to do this in like 4 words, but we're not going to. Well, we will, but then we'll see different takes on it. We just have a bunch of examples. It's all pretty much the same stuff, but how is it going to differ with the different looks that the problems will give you? And so, the basic of it, we have a radical equation. Square root equals a number. Here we have the square root of x minus 9 equals 5. And so, we have to think, well, the square root of something equals 5. What would that number be? Well, the square root of 25 equals 5. So wouldn't it make sense that x minus 9 would have to equal 25? So the square root equals 5? Sure. The other way we get here is by squaring both sides. Right? If we have something squared equals a number, we take the square root of both sides. If we have the square root equals the number, we square both sides, and we get to x minus 9 equals 25. And then from there, we're just solving a linear equation. Add 9, x equals 34. We do want to check to make sure it's in the domain. Won't be an issue for these first few problems, but that is nice. X minus 9, what's underneath the square root, has to be greater than or equal to 0, which means x has to be greater than or equal to 9, and 34 is greater than or equal to 9, so x equals 34 is the answer. For a lot of these, this process could happen in your head. The other thing you could do is plug it in. 34 minus 9 is 25. Square root of 25 is 5. It makes sense. There's nothing weird happening. Specifically, we don't get a negative underneath the square root, which leads to all sorts of problems. Or we don't have the square root equals a negative number, which would also be unfortunate. And so that's the basic idea of what we're doing. The rest of the examples are just going to help firm that up and show you a couple other things that might happen along the way. So here's an example. We have a square root equals a square root. Square root of 3x minus 1 equals the square root of 2x plus 4. So if we have a square root equals a square root, wouldn't it make sense that the inside has to equal the inside of this one? Yeah, and sure enough, it does. We could also get there by squaring both sides, which I thought I had done, but apparently not. Anyway, so the inside equals the inside. We can subtract the 2x to get x, add the 1 to get x equals 5. And then from here, we want to make sure this is in the domain of each of them. One way we could do it is to just plug 5 in. 3 times 5 is 15, minus 1 is 14. What's the square root of 14? I don't know, 9 point something. But over here, 2 times 5 is 10, plus 4, square root of 14. I don't know, it's 9 point something. But what I know is the square root of 14 does equal the square root of 14. So that's one way we could do it. The other way, we could find the domain. Over here, 3x minus 1 has to be greater than or equal to 0. Add 1, then divide by 3. So x has to be greater than or equal to 1/3, which 5 is. Over here, 2x plus 4 has to be greater than or equal to 0. Subtract 4, divide by 2. X has to be greater than or equal to negative 2, which 5 is. But for this, we have 2 domains. If that happens, you only actually need one of them. Which one would satisfy both? Everyone always likes to go to the smaller one. No, because negative 1 is bigger than or equal to negative 2, but it doesn't work here. So it's actually the bigger of the two numbers. So really, the only piece of the domain we need, x has to be greater than or equal to 1/3. That will make both of these work. But, as we pointed out, 5 is bigger than both of them, and so x does equal 5. Another problem, this one looks pretty much the same, but there is a small change. This 2 here is on the outside of the square root, which isn't a big problem, but it is one of the common mistakes that people make. We square both sides. See, I had it there. We square both sides, and people say, okay, 2x. No. The square root of x squared will give us x, but what is 2 squared? 2 squared is 4. So this 2 root x squared is 4x equals x plus 9. And then we solve it from there. Subtract x to get 3x equals 9, divide by 3, x equals 3. We can plug them in. 2 times root 3 equals root 3 plus 9, that's root 12. Root 12 is 4 times 3, which is 2 times 2 times 3, which does simplify to 2 root 3. So x does equal 3. And another one, it's like, okay, well, here we have a root equals a root, but these are fifth roots. Is that going to change anything from the square roots? Not really. One thing it means is that we don't have to worry about negatives underneath the root because it's an odd. Remember, the odd roots have all real domain. The other thing that it changes is instead of squaring both sides, we'd have to take the fifth of both sides, which all that's going to do is cancel out the root. So we get x plus 4 equals 3x minus 2. We can subtract the x over, add the 2 to get 6 equals 2x. Divide by 2, x equals 3. Plug it in. We have the fifth root of 3 plus 4 is 7. All right. Don't know what that is. 1 point something. And the fifth root of 9 minus 2 is 7. Again, fifth root of 7 equals fifth root of 7. X equals 3. And so do you see how these are all kind of the same? Let's keep working because there's some that are going to be a little bit different. Here, we have the square root of 3x minus 11 equals x minus 3. Well, we're going to do the same thing. We're going to square both sides. When we square this side, we'll get 3x minus 11. But when we square this side, this is not x squared minus 3 squared, or x squared plus 3 squared. X minus 3 squared is x minus 3 times x minus 3. So when we multiply that out, we get x squared minus 6x plus 9. Don't forget to be doing that. That would be the other big mistake people make in this area. Well, up here we then had a linear equation. Down here, we have a quadratic. That's okay. We can deal with quadratics. First step in dealing with a quadratic is to get it equal to 0. So we'll subtract the 3x over to make a negative 9x, add the 11 to make it plus 20, and we get 0 equals x squared minus 9x plus 20. And then factor. Now these ones, like the whole purpose is not about the factoring. These factors should be pretty easy. Specifically, you should probably have just x squared. You won't have 2x squared or 3x squared. It'll probably just be x squared. So when we factor this, let's see what times what equals 20, but adds together to get negative 9, negative 4, and negative 5. So x minus 5 times x minus 4 equals 0, which means if x minus 5 equals 0, x can equal 5. If x minus 4 equals 0, x equals 4. Now when we have these, a lot of times one of these two answers will not work. It's possible that they both will work. It's possible that neither will work. But a lot of times one of them will and one of them won't. So we can check this. And there's a couple ways of doing that. One is to go back to the domain. But the problem with that is that sometimes it'll work with the domain, but it won't work with the equation. So to check these, I would just plug it back in. Plug in 5. 3 times 5 is 15. Minus 11 is 4. Square root of 4 is 2. 5 minus 3 is 2. So 5 works. Plug in 4. 3 times 4 is 12. Minus 11 is 1. Square root of 1 is 1. 4 minus 3 is 1. 1 equals 1. So 4 also works. So this is one of the occasions where they both actually end up working, which is fine, and it will happen. It's just not as common. So let's look at another one like this. The square root of negative x minus 1 equals x plus 1. First step, we need to square both sides. When we do that, the square root goes away here. The negatives stay. People like to try and make it positive because when you square things, it becomes positive. But it gets rid of the square root. The negatives stay, and this becomes x squared plus 2x plus 1. We can add an x over to make 3x, add the 1 to make a 2, to get 0 equals x squared plus 3x plus 2. And we can factor again. Let's see, what times what equals 2? Not many options there. 2 and 1. And hey, look, they add together to give us 3. How convenient. And so, x can equal negative 2, and x can equal negative 1. If we plug this in, negative 2 is just 2, so we have square root of 2 minus 1, and then negative 2 plus 1. 2 minus 1 is 1. Negative 2 plus 1 is negative 1. So we get the square root of 1 equals negative 1. But the square root of 1 doesn't equal negative 1, so that does not work. And you might be thinking, wait, but when we square root, we get plus or minus. You're partially correct. When we square root both sides, we get plus or minus. If we have x squared equals a number, and we square root both sides, both the positive and negative will work. By definition, though, the square root only gives us the positive of the answers, so it will not give us negative 1. So x minus 2 does not, or x equals negative 2 does not work. Let's plug in negative 1. Negative 1 is positive 1, so we'll have the square root of 1 minus 1 equals negative 1 plus 1. We can simplify. 1 minus 1 is 0. Negative 1 plus 1 is 0. We have the square root of 0 equals 0, which is a true statement. And so x equals negative 1 does work. And that would be the solution to the equation. We don't need the x equals negative 2. Does not work. And that happens because when we square both of these, that negative 1 that we had here ended up becoming positive. And so weird stuff happens when you start squaring things. All right, so we have some where we end up with quadratics. Couple more twists. What if we have x minus 5 to the 1/2? This would be an exponent, equals 3. Isn't that the exact same thing as saying the square root of x minus 5 equals 3? We dealt with rational exponents. This would be the root, so it's a square root of x minus 5 equals 3. Square both sides, x minus 5 equals 9, add 5, x equals 14. If we plug 14 in, 14 minus 5 equals 9, square root of 9 is 3, so x does equal 14. There's not much to this one, it's just that the exponent sometimes trips people up. You might be thinking, wow, we did a lot of square root, square root, square root, square root, square root, square root. Well, this is the fifth root, but it doesn't even really count because they're both fifth roots. What about other roots, like cube roots? We will work with those a little bit, but not too much. Mostly we're going to be dealing with square roots. However, if we have a cube root, we deal with it just the same. The cube root of x minus 2 equals 2. Instead of squaring both sides, cube both sides. These will still cancel, so we get x minus 2 equals 2 cubed, which is 8. Add the 2, x equals 10. And if we plug in 10 minus 2 equals 8, cube root of 8 equals 2, and we're good. So x equals 10. So this is how we can solve radical equations. Again, it's the same thing. The general idea, square both sides, solve from there. Or cube both sides, solve from there. And then check your answers to make sure that they work. So let's see, square both sides, solve from there. I can explain it in 6 words. So that's equations. How about inequalities? Inequalities are going to be solved exactly the same, but here finding that domain is going to be very important. So if we start out with something like the square root of x plus 5 is minus 1 is less than or equal to 4, first thing, find the domain. This underneath the square root has to be greater than or equal to 0. So x plus 5 is greater than or equal to 0. Subtract 5. X is greater than or equal to negative 5. This will probably be part of our answer. In equations, we would just use it to check our answer, but here is going to be part of our answer, most likely. So let's go back to the equation. We can add 1 to get the square root of x plus 5 is less than or equal to 5, and then square both sides. X plus 5 is less than or equal to 25. And notice I didn't worry about switching the sign because we only have to switch the sign when we multiply or divide by a negative. Well, 5 is a positive number, so that's not a problem. And square roots are always positive, so that's not a problem. So we don't have to worry about switching the sign so much. If you did have an occasion where you had a negative over here and you had to square it, I would just make it equal and then do a sign graph like we've done for polynomials and things like that. But you shouldn't have to worry about that. Anyway, x plus 5 is less than or equal to 25. Subtract 5. X is less than or equal to 20. But it's not everything less than or equal to 20 because we have a lower bound here. It has to be greater than or equal to negative 5. And so we can put that in a compound inequality. Negative 5 is less than or equal to x is less than or equal to 20. Notice we had to switch the order on this one. It's pointing at the negative 5. It's still pointing at the negative 5. So there we go. Also notice in none of these, I never subtracted 5 here. Don't subtract out of the square root. You can't do that. That would be bad. That would lead to very bad things happening. We square both sides. Another one like this. Square root of 8x plus 1 is greater than or equal to 7. First step, 8x plus 1 has to be greater than or equal to 0. Subtract 1. Divide by 8. X is greater than or equal to negative 1/8. Then back here, we can square both sides. Get 8x plus 1 is greater than 49. Subtract 1. 8x is greater than 48. Divide, x is greater than 6. And so it has to be greater than 6, but it also has to be greater than this. But this doesn't really have anything to do with this because numbers bigger than 6 are also bigger than that. And so it's just x is greater than 6. If this was x was less than 6, we'd write it like this, except this would just be a less than. The one here, the one involved with the domain, is always an or equal to, because it could equal that number. The one involved with the solution will be whatever the original problem said. Anyway, so solving radical inequalities is basically the same as solving the equations, except that we have to think about our domain as part of our answer and not just checking our work. Anyway, that's solving radical equations and inequalities. I hope you enjoyed. Be ready for class with an activity, and I will see you then.